Private VLANs are really a way to separate one large broadcast domain into smaller subdomains. So when we have, let's say, switches here that are running just in a regular mode, and we have VLAN, let's say VLAN 1, all hosts on all switches in this VLAN 1 can actually talk to each other. So we can say that all these hosts here are in the same broadcast domain. Now, when we say broadcast domain, of course, we mean that they can see each other's broadcasts, but that also implies unrestricted communication between them on layer 2. Now, sometimes you want to have a situation that you want to have on one switch some hosts that actually cannot talk to each other, but they are, for whatever reason, in the same VLAN. Now, what would be the reason for these hosts here to be in the same VLAN, but not to be able to talk to each other? Well, of course, one of the reasons would be security, and the other reason could be scalability. Now, why do I say scalability? How does scalability figure into this? Now, imagine that if I wanted to have, for example, one host here that was separated from this host here, and I still wanted them to be able to talk to, for example, internet that is behind a host that is connected here. What I would need to do is I would need to put these in one subnet, and I would need to put these into another subnet here, which means that I would need two subnets. Now, if I need two subnets on Ethernet, that means that I'm losing two IPs. I'm using the network IP and that I'm using the broadcast IP. Now, if I have a really large number of these hosts, let's say that this is some sort of a hosting facility, or let's say that this is a, I don't know, a service provider access ring where you have customers that you don't want to communicate directly, that means that you are going to be losing a lot of IPs just because you need a lot of subnets. So now, wouldn't it be a better idea that we provide some sort of layer 2 isolation between these hosts while still keeping them on the same subnet, actually losing this overhead here? The first feature that Cisco came up with to support this kind of separation, this kind of segregation inside the same VLAN, was something that was called protected ports. Now, protected ports worked just fine, and they worked in such a way that we would declare, for example, this port here and this port here as protected ports. So this one here would be protected, and this one here would be protected port, and this one here would be just a regular port. And let's say that this was VLAN 10. So the host here in VLAN 10, so let's say that this is host 1, that this is host 2, and that here this is host 3. Host 1 would be able to communicate with host 3, but would not be able to communicate with another protected port. The same thing here with this host 2. It cannot communicate with the protected port, but they can communicate with all the normal ports. And protected ports are still supported today, and you can configure them if you go to interface X and you say switch port protected. You're basically going to enable this feature here. This provides for this, for the lack of better word, segregation inside this VLAN. So this is still considered to be the same VLAN, but these two hosts can no longer send traffic between each other because they are behind these protected ports. Now, protected ports were very good feature as long as you used only one switch. And the reason there was that if we added a trunk here, for example, and we had another switch that had a protected port here, this switch here was not aware of any configuration of the protected ports here and the other way around. So we were unaware that these protected ports existed. This is where private VLANs come into play. They basically extend the protected port feature to multiple switches, and they also provide for some other functions. Now, first thing to talk about private VLANs is some of the terminology that we use there. First thing is we have a primary VLAN. Primary VLAN is really, I like to think of it as a container for other smaller broadcast domains. Which are also called secondary VLANs. Secondary VLANs is this smaller broadcast domain. Or we can say it's a subdomain of the primary VLAN. The next thing is that secondary VLANs come in two flavors. We have isolated, which basically provides same functionality as protected ports. And we have community VLANs, which allow communication inside the community but not to other communities or isolated VLAN. And finally, we have something that is called promiscuous port. So let me just move this up a little bit. We have not promiscuous VLAN, but promiscuous ports. And these can communicate with all secondary VLANs. So basically, promiscuous ports allow this functionality. They are just like the normal port in the protected VLAN setup. So to explain this, let's take a look at one switch. So this is going to be our switch here. And on this one switch, we are going to have, let's say, 2 ports, and I want these ports to be isolated from the rest of the world. Now, I want to have the following 2 ports be able to actually communicate to each other, but not to anyone else. And I want the same thing for the following 2 ports. So these 2 ports here should be able to communicate to each other. These should be able to communicate to each other, and these should be isolated from everyone else. Now, let's say that I have these 2 ports here that are actually acting as uplinks. So let's say that there are some internet connections here. So these 2 ports, these 2 ports here, they are going to be isolated. This here is going to be community. And this one here is going to be community, but it is going to be separated community. Now, all this here is actually going to be part of one large primary VLAN. So let me maybe do that somehow else. So all this stuff, including these 2 other ports, so maybe I should really move them someplace else. Let's see if I can do that. So these 2 ports here they are really, these are all part of primary VLAN. And I can say that these ports here are promiscuous. Now, all these are part of the primary VLAN, and I won't be needing the, I won't be needing these two lines here. Now, the scenario behind this, the story behind this configuration could be that, let's say that this is some sort of a co-location facility or something, and behind the promiscuous ports we have redundant internet gateways. Now, isolated ports are customers who might have just a single server or single machine connected to our switch, and the community VLANs may be those customers or users that might have multiple devices connected here. Now, when you are configuring private VLANs, there are a couple of requirements, couple of prerequisites that you need to do. Number one is that your switch must operate in VTP transparent mode. Once you have done that, you need to create primary and secondary VLANs. Configure secondary VLANs as needed. And then associate secondary VLANs with the primary one. So let's take a look at an example for that. Let's say that our primary VLAN here is going to be, let's say, 100, that our community 1 VLAN is going to be 101, that our community 2 VLAN is going to be 102, and let's say that we want our isolated VLAN to be, let's say, 110. So let's see how the configuration for this might look. And let's say that this is port 1, 2, 3, 4, 5, 6, 7, and 8 on the switch. So to take a look at this configuration, what I'm going to do is I'm going to create and put my switch into the VTP transparent mode. That's the first thing that I'm going to do. Then I'm going to create primary and secondary VLAN. So I'm just going to say VLAN 100, and I'm going to say private VLAN, primary. Then I'm going to create secondary VLAN, so it's going to be 101. I'm going to say private VLAN, community, VLAN 102, same thing, and VLAN 110 is going to be private VLAN isolated. Now, let me see what would happen if I pasted this into my configuration here. So I'm going to just connect to one of my switches. And if I paste this configuration in, okay, VTP mode transparent, maybe I just need to do that. So let's do that. So now if I do show VLAN, private VLAN, this is going to be the configuration that I will have. As the result of this configuration, this is what I have on the switch. Now, when you have output that looks like this, there is a little bit of a problem, because now we have the primary VLAN and we have 3 secondary VLANs, but they are not actually connected. There is no relationship between them, because you see here, for this primary VLAN, there is no secondary VLAN associated, and for these secondary VLANs here, there is no reference to which primary VLAN they belong to. This is why that last step of actually associating secondary VLANs with the primary is important. So I'm going to go back to VLAN 100, and I'm going to say private VLAN association, and then I'm going to associate this VLAN with the 3 of my secondary VLANs. So if I go and paste this back in here, oops, oh, it's not 103, it's 101, 102, just a tiny little typo. So I'm going to do this. So now if I do show VLAN, private VLAN, this is what I'm seeing. Now you can see how this output is different than the other one. So here, at this moment here, I see that this is a primary VLAN 100, and this primary VLAN 100 is actually associated with these secondary VLANs. Now, I should also point out that you can have, I would say, any number, and take this with a grain of salt because I'm sure that there is some limitation, but I have never actually bothered to check what limitation is. You can have any number of community VLANs, but you can have only one isolated VLAN associated with the primary VLAN. Now, why is that? Because do you really need multiple isolated VLAN? The hosts in an isolated VLAN cannot talk to each other anyways. They don't have the ability to talk to each other. So do you really need to have 2 separate VLANs to provide for the exact same functionality? You don't. So one isolated VLAN per primary VLAN is more than enough. Now, when it comes to community VLANs, yeah, you could have multiple arrangements where you have multiple ports that are actually parts of these communities, that you have large number of communities. So this was the basic setup. Now let's go and take a look at how do we actually configure different ports. So we configure different ports, and we can say interface range fastnet 01 to 2. So this is going to configure our isolated ports, and here I'm going to declare them at switch port mode private VLAN host. This tells the switch that this is going to be a host port and not a promiscuous port. Then we are going to say switch port private VLAN host association. So here we need to associate this host with the primary VLAN. So we are telling it this is primary VLAN 100, and you are actually going to be a host that is using secondary VLAN 110. So here we are basically telling that these 2 ports are going to be part of VLAN 110. Now, very similar configuration goes on ports 3 and 4. These are members of the community, but the only difference in the configuration is the secondary VLAN that I'm doing. And the same thing is for ports 5 and 6. So they are just going to be members of 102 here. And let me move the notepad to this side because I need to extend it a little bit more down. And our promiscuous ports, our ports 8 and 9, are going to be promiscuous ports, and here our configuration is slightly different. Instead of using host association, we are going to say mapping, and then we say this is promiscuous ports in a primary VLAN 100, and we want it to be promiscuous for secondary VLANs 101, 102, and 110. Now, mind you, in this task here, actually these were ports 7 and 8. So in this task here, we had a requirement that these are promiscuous ports for all these VLANs. But let's add port number 9, for example. So this is port number 9, and we want this port to be, let's say, a promiscuous port for only VLANs 101 and 102, but not for 110. Now, we can do that as well, so I'm just going to repeat this configuration here, and this is going to be interface fastnet 09, and this is going to be now promiscuous for only VLANs 101 and 102. Now, let's add port number 10 here. That is going to be, let's say, promiscuous for just VLAN 110. So if we add that into our configuration here, it is going to look like this. So let me paste these configs in to my switch and see what's going to happen. So if I do now show VLAN, private VLAN, this is what I will be seeing. For VLANs, for VLAN 101, I have ports 3 and 4 that are members there. So this is our community number 1. And I have promiscuous ports 7, 8, and 9 involved here. And this is exactly what I had. 7 and 8 are promiscuous for all VLANs, and then 9 is promiscuous for VLANs 101 and 102. So this is what I'm seeing here. Now for VLAN 102, I see that ports 5 and 6 are members, and then I have 7, 8, and 9 that I have associated as promiscuous ports. For VLAN 110, I have ports 1 and 2 that are members, 7 and 8 are promiscuous for them, and I can see here that fast Ethernet 010 is also associated with this VLAN here. So this is the basic configuration of private VLANs, and if you repeat this same configuration on the other switches, they will actually be aware that the traffic coming from isolated VLAN is not allowed to go to those isolated ports. The question here was, did this command show the commands that are only promiscuous for a particular VLAN? I don't believe that you might have that command, but you can do show interface fastnet 010 switch port, and here it will show you. If it shows you the mapping, it is going to be a promiscuous port, but if it shows you host association, well, not even that. Let me see. I don't think that there is a command that will show you just the promiscuous ports. At least I cannot remember that. I cannot remember that there is a command that would do that. So I'm just looking now, and show VLAN. Maybe if I do internal, but no, this is going to be the usage of internal VLANs. This is something completely else. No, I don't think that there is a command that will show you just promiscuous. Show VLAN, private VLAN actually does. So this command here just shows you which ports are mapped to which secondary VLAN. That's the only thing this command does. And it also, of course, tells you to which primary VLAN these ports belong to. So here we see that they all belong to 100, so this is their primary VLAN for all these ports, but they all belong, so these ports here belong to secondary VLAN 101, these belong to secondary VLAN 102, but you can see that promiscuous ports can actually belong to multiple secondary VLANs, but they can belong to only one primary VLAN.